So hello dear students and welcome to today's topic on probability. So हमारा overall जो objective है is to take you from basics to the level where you will be able to solve the problems of JEE or any other competitive exams of same level or maybe higher or lower level, or at the same time you do well in your exams at school level like board or maybe 11th standard. So before we move ahead, it is a humble request कि प्लीज़ हमारे इस वीडियो को और इस चैनल को सब्सक्राइब करिए, लाइक करिए और कमेंट भी करिए। आपका फीडबैक वो पॉजिटिव हो या नेगेटिव हो हमारे लिए बहुत ही इंपॉर्टेंट है। हमें वो मोटिवेट भी करता है आने वाले वीडियोस को बेटर प्रिपेयर करने के लिए, ताकि अल्टीमेट जो हमारा ऑब्जेक्टिव है, मिशन है कि आपको जेई लेवल के एग्ज़ाम्स तक के लिए हम तैयार करवाएं और आपकी हेल्प करें कि आप उस लेवल तक पहुंच सकें। तो इसलिए आप प्लीज़ इसको लाइक, सब्सक्राइब, शेयर, कमेंट्स करना ना भूलें। So with this, let's get started. So probability, as we all know, that probability is a measure of the likelihood that an event will occur. So basically हमारा जो भी कोई event होता है उसके उसके likelihood क्या है, that is the only thing which the numerical expression of that particular likelihood of particular event is known as probability, जैसा कि हम अपने आम बोलचाल की भाषा में जानते हैं। सो प्रोबेबिलिटी का जो किसी भी इवेंट का अगर वो पॉसिबल है इवेंट, तो उसके होने की लाइकलीहुड जो होती है वो बिटवीन 0 to 1 होती है, इंक्लूड बोथ इंक्लूसिव। सो लेट्स से कि अगर हमने कोई कॉइन को टॉस किया और कॉइन के टॉस करने के बाद में इफ़ वी वांट कि व्हाट इज़ द प्रोबेबिलिटी ऑफ अकरेंस ऑफ हेड, सो अगर वो फेयर कॉइन है, सो दोनों ही साइड हेड या टेल के आने की प्रोबेबिलिटी इक्वल इक्वल है। सो डेफिनेटली हेड आने की प्रोबेबिलिटी भी 0.5 होगी और टेल आने की प्रोबेबिलिटी भी 0.5 होगी। सिमिलरली अगर हमने किसी डाई को अगर रोल किया, तो डाई में एज यू ऑल नो कि उसमें टोटल 6 साइड्स होती हैं 6 नंबर्स के साथ में। सो किसी भी नंबर के आने की प्रोबेबिलिटी लेट्स से 4, so because total number 6 हैं, total different 6 faces हैं, so it's 1 by 6, it is near less than half, it is near to 0, and similarly the probability of any event varies from 0 to 1. So as we move towards 1, the likelihood of that particular event, we can say that it is more than any other event for which it is less than that particular event. So it can be expressed numerically as this: probability of any event E is between 0 to 1. So let's simply jump to the question here. बहुत ही easy question है बेसिक्स से, क्योंकि हमारा फंडामेंटल हमारा जो मिशन है कि फंडामेंटल को देखते हुए और फिर क्वेश्चंस के लेवल को रेज करें, बीच में जेई के भी क्वेश्चंस कुछ हम सॉल्व करेंगे। So let's see, a coin is tossed twice. What is the probability that at least one tail occurs? So अगर हमने एक कॉइन को 2 बार टॉस किया या फिर और 2 कॉइन को एक एक करके टॉस किया, दोनों चीज़ें एक ही होती हैं। दिस वी शुड बी वेरी क्लियर, इट डजंट मेक एनी डिफरेंस whether we toss the same coin 2 times or we toss 2 different coins individually. So let's take any of the case, because क्वेश्चन में यहाँ पे ये बोल रहा है तो हम इसी को लेते हैं, बट इट डजेंट मैटर, आप किसी भी तरीके से इसको ले सकते हैं क्वेश्चन को। सो अगर हमने टॉस किया, सो क्या प्रोबेबिलिटी है कि एटलीस्ट वन टेल अकर। सो टोटल नंबर ऑफ पॉसिबल आउटकम्स क्या होंगे इसमें, एज वी नो कि फर्स्ट जब टाइम हमने टॉस किया तो हेड भी आ सकता है या टेल भी आ सकता है। सिमिलरली जब सेकंड टाइम हमने टॉस किया तो हेड भी आ सकता है या टेल भी आ सकता है। तो टोटल नंबर ऑफ पॉसिबल आउटकम्स कितने होंगे 2 बार जब टॉस करेंगे हम? सो आइदर हेड हेड और हेड टेल और टेल हेड और टेल टेल। सो टोटल नंबर ऑफ पॉसिबल आउटकम्स आर 4। दिस कैन ऑल्सो बी कंसिडर्ड एज, आप इसको ऐसे भी ले सकते हैं, क्योंकि अगर हर बार इस तरीके की कॉम्बिनेशन बनाना हो सकता है डिफ़िकल्ट हो जब क्वेश्चन हमारा लेंदी हो। लेट्स से कि अगर मैंने ये बोला होता है कि लेट्स से कि अ कॉइन इज टॉस्ड 8 टाइम्स, सो 8 टाइम्स के डिफरेंट कॉम्बिनेशंस ऐसे लिख लिख के बनाना इज अ डिफ़िकल्ट थिंग ना। तो बेसिकली कॉन्सेप्चुअली हमें पता होना चाहिए कि हम क्या कर रहे हैं यहाँ पर। सो हम क्या करेंगे, हम ऐसे स्पेस ऐसे बना लेंगे अपने स्क्रैच बुक में, रफ शीट में, और उसके बाद जब हम हर एक इवेंट को लिखेंगे उसके पॉसिबल आउटकम्स को, तो फर्स्ट टाइम जब हमने यहाँ पे टॉस किया कॉइन को, सो कितने नंबर ऑफ आउटकम्स पॉसिबल हैं? दो। वाई दो? क्योंकि हेड भी आ सकता है और टेल भी आ सकता है। सिमिलरली सेकंड टाइम जब हमने कॉइन को टॉस किया, तो अगेन दो पॉसिबल आउटकम्स हैं, हेड एंड टेल। सो एंड बिकॉज जो सेकंड टाइम हमारा जो आउटकम है वो फर्स्ट टाइम के आउटकम से बिल्कुल इंडिपेंडेंट है, राइट? अगर हमें फर्स्ट टाइम जो भी आउटकम मिला उसका कोई इफेक्ट नहीं है सेकंड टाइम के आउटकम पे, विच वी कैन सी इट इंट्यूटिवली। दो जब हम इंडिपेंडेंट इवेंट्स को पढ़ेंगे समझेंगे तो उसको और डिटेल में इसका डिस्कशन करेंगे। बट एज ऑफ नाउ यू कैन वेरी वेल थिंक दिस लॉजिकली कि ये दोनों इवेंट्स आपस में इंडिपेंडेंट है। मतलब इवेंट ऑफ द हैपनिंग ऑफ वन पर्टिकुलर इवेंट डज नॉट अफेक्ट इवेंट ऑफ द अदर occurrence ऑफ द अदर इवेंट। सो बिकॉज इंडिपेंडेंट हैं तो इनमें हम मल्टीप्लाई कर देंगे 2 into 2। इसको ऐसे भी समझ सकते हैं हम कि हम ट्री डायग्राम बनाते हैं, विच इज़ नॉट इम्पॉर्टेंट हियर एज फार एज वी आर इफ वी आर क्लियर इंट्यूटिवली। सो अगर हम ऐसे भी देखें तो लेट्स से फर्स्ट कॉइन को टॉस, फर्स्ट टाइम को टॉस किया तो हेड आया। देन हेड आने के बाद में सेकंड टाइम टॉस करके जो आउटकम पॉसिबिलिटी है उसमें हेड या टेल है। और अगर अगर फर्स्ट टाइम में टेल आया होता तो अगेन सेकंड टाइम में आने की पॉसिबिलिटी हेड या टेल है। सो इससे हमारे पॉसिबल आउटकम्स क्या बन रहे हैं? ये हेड हेड, और फिर ये हेड टेल, फिर ये टेल हेड एंड टेल टेल। सो 4, यहाँ पर भी 4, और ये भी हमने जो देखा 4। सो टोटल नंबर ऑफ पॉसिबल आउटकम्स कितने हो गए? वो हो गए 4। अब हमारा जो फेवरेबल आउटकम है हम उसको देख लेते हैं थोड़ा। सो फेवरेबल आउटकम क्या बोलता है? एटलीस्ट वन टेल अकर्स। सो लेट्स ड्रॉ इट, वन टेल अकर्स। सो टेल हेड, इसके दो कॉम्बिनेशन बन जाएंगे, हेड टेल भी हमारा चलेगा, और सो दिस, और दोनों टेल आ जाए बिकॉज एटलीस्ट वन टेल है। सो दिस ऑल्सो विल fulfill the condition. So their total number of possible outcomes 3 हैं. So therefore probability of at least one head, sorry, one tail is equal to 3/4। ठीक है, इसको हम एक तरीके से और देख लेते हैं। probability लेट्स से अगेन फेवरेबल आउटकम कि एटलीस्ट वन टेल आए। सो दो हम स्पेस बना लेते हैं, तो टेल हेड या फिर हेड टेल या टेल टेल, ये हमारे फेवरेबल आउटकम्स हैं ये तीनों। सो प्रोबेबिलिटी ऑफ वन टेल आने की कितनी प्रोबेबिलिटी है? 1/2। वन हेड आने की कितनी प्रोबेबिलिटी है? 1/2। और ये तो हमारे हो गए रिक्वायर्ड इवेंट्स। और फर्स्ट टाइम में हमारा हेड आ सकता है, ठीक है। देन सेकंड टाइम में टेल आना चाहिए फेवरेबल आउटकम के लिए, प्लस दोनों टाइम में टेल टेल आ जाए, मतलब 1/2 × 1/2। सो इसको अगर सब हम सॉल्व करेंगे तो वी विल गेट 3/4। सो डू इट इन एनी वे, बट कॉन्सेप्चुअली वी शुड बी वेरी क्लियर कि हम कैसे करना है, क्या करना है। तो वी कैन अप्लाई एनी ऑफ द अप्रोचेस मेंशन्ड हियर और इजीली इसको सॉल्व कर देंगे। क्वेश्चन वाज वेरी इजी, आई नो दैट ऑल ऑफ यू नो दिस, but still I will request ki be patient, we will raise the level and we will go step by step, because in coming videos, this is the first session on probability, in coming videos we will raise the level of questions drastically, and even in this video also you will see the level of questions going up as we move ahead. So be a little patient and bear with me, though I know for those who already have gone through the chapter of probability from class 11th and 12th, it will be a little, you know, sort of boring for them, but still I will request. So again, we will do this quickly. A card is selected from a pack of 52 cards. Okay, so I hope everybody knows here about cards in probability, coin and die and cards. This we should definitely know. Okay, so the things should be in on our fingertips. So there are 52. Okay, so there are four type of cards. One is diamond, and one type is heart, These two are in red in color. Then let's take black color. So one is spade, just like this, and one is club. So these two are black in color and these two are red in color. So each category or each type of cards have these numbers like ace, then J, K, Q, that is queen, and from number 2 to number 10. So these total 13 cards. So every card, every type of card has these 13 cards. Okay, so the sum total becomes 52. Now with this little debriefing, I would say, let's jump to the question. How many points are there in the sample space? So there are total 52 points sample space. We will be discussing what are sample points and what are sample space, but because we know that there are total 52 cards, so 52 sample points हैं यहाँ पर. Calculate the probability that the card is an ace of a, let's take a red color, that the card is in a space of is an ace of spades. So where is our spade? So spade is here. तो इसमें भी हमारा ace एक होगा, ठीक है. सो ये एक यूनिक कार्ड है, तो इसकी प्रोबेबिलिटी क्या हो जाएगी? 1/52. फाइन. Total number of cards are 52 and ace of spade is only one, the second one. Okay, so therefore 1/52. Then calculate the probability that the card is an ace. Okay, so there are total 4 aces. Why? Every type of card has same set of cards. So here is one ace, here will be one ace, here will be one ace, and here will be one ace. So total 4 aces, and number of total cards are 52. So this is our, so we can simplify this 1/13. So this will be 1/13. And black, so their total, as we have seen, total 26 cards are black. So 26 by 52, or this will be 1/2. So this is 1/2. Now move to the next question. A die is thrown. Find the probability of the following events. A prime number will appear. Okay, so when a die, let's just draw simply 1, 2, 3. I'm just doing it randomly. So these are the numbers on die. So prime number will appear. So there are total 3 prime numbers, 2, 3, 5 on a die. So total 3 favorable outcomes. So definitely, and total number of possible outcomes are 6, from 1 to 6. So therefore the probability of this will be 3/6, that is 1/2. Then a number greater than or equal to 3 will appear. So greater than or equal to 3 means it will be 3, 4, 5, 6. So that means we have 4/6. Okay, a number less than or equal to 1 will appear, less than or equal to 1. So it will be 1 only, because less than 1 will be 0, which is not the case in case of die. So 1/6. A number more than 6 will appear, so it is 0. It is not possible, because there are total 1 to 6 numbers on a die. A number less than 6 will appear, so less than 6 means all the numbers from 1 to 5. So total 5 possible outcomes, 5 favorable outcomes, and possible outcomes are 6. So 5/6. Now we will move to the next question. Just a second, why it is not moving? So yeah, so as we have seen, probability of, definition of probability, so no need to repeat. Ratio of favorable outcomes to the total number of possible outcomes. And these are some of the properties. There are more properties, but these are some of the basic properties, as we have seen this in first case. And then probability of any event and the complement, and uh, the complement of that event. If we do addition, so it will be 1, that is the probability of any event, and if we add this to the complement of that particular event. So we can simply say that, let's take a case of die, and we say that probability, we want a favorable outcome as, let's say, a number less than 3, so these are 1, 2, and we then the complement of this particular event will be what? uh, More than or equal to 3. Okay, because those events which are not in the given event, so those will be complement events. So this will be 3, 4, 5 and 6. So and our probability of 3 coming less than 3 will be 2 by 6, and probability of complement of the event will be 4 by 6. So this will be 6 by 6, that is 1. So it is simply saying this only. And if events are independent, so we will again discuss it later, but as of now we can understand that if two events are independent, so the combined probability of these two events will be product of individual events. So let's now quickly learn some of the or maybe go through again some of the terminologies which are very important to know their meaning, and because without knowing them correctly or maybe in clearly, it will be difficult to solve the problems of a higher level or maybe difficult level. But if we have clear understanding, at least we can say that yeah, the approach will be in the right direction. Again, if approach making our approach in the right direction is very important, very crucial as far as problems of JEE level, solving those problems are concerned. So sample space, so sample space is the universe of any experiment where all the number of possible eventualities or events can be given or can be measured. So let's say again, अगर हम किसी अगर deck of cards से let's say हम कोई भी एक्सपेरिमेंट करते हैं, टोटल नंबर ऑफ पॉसिबल जो उसमें कितने बनेंगे वो 1 से लेके 52 कार्ड्स तक के होंगे. तो दिस इज अवर सैम्पल स्पेस. अगेन अगर हम किसी डाई को रोल करते हैं, या लेट्स से अगर हम किसी दो डाई को रोल करते हैं, सो हमारे टोटल नंबर ऑफ पॉसिबल आउटकम्स कितने बनेंगे? टोटल 36. वाई? बिकॉज इसमें 6 पॉसिबल आउटकम्स हैं 1 to 6 नंबर तक के, और सिमिलरली इसमें भी 6 हैं. तो 6 into 6, because these two events are independent, as we can see it logically. So there are total 36 possible outcomes. So those possible outcomes we can also write them, like for example 1, 6, that is on the first die it comes 1, and on the second die it comes 6. Similarly 1, 5, 1, 4. Similarly all those 36 number of combinations we can write. So those are our sample space. Those are our sample space, because that is the universe under which the universe of the experiment for which we are interested in measuring any particular event. So as sample space is denoted as S, and if we take the example of tossing of two coins, so these are our sample spaces. So HH, HT, that is head head, head tail, tail head, and tail tail. So these are our sample space. Event, again the particular thing which we are interested out of that sample space. So this is basically a subset of a sample space. So let's say again going with the same example, tossing of two coins. So let's say we are interested in knowing the probability or the event in which one head comes and one tail comes. So we can write this as HT, that is head tail, and tail head. Okay. So these are subset of our universe. Fine. So event is nothing but subset of our universe. Impossible events which can't happen. If I say, let's say if I roll a dice, and if I say that what is the probability of getting a number 7, so because 7 doesn't exist, so this event will be called the event of getting number 7 is an impossible event. Sure event which is definitely going to happen. Again, let's say if I roll a dice and I say that what is the probability, tell me the events on which either it comes a prime number, it comes either a prime number or or prime odd prime number or even numbers. I've just taken one example. So odd prime numbers are which? 3 and 5 in a die, and even numbers are which? So these are 2, 4, 6. So if we No, sorry. Then we also have to write odd prime number or even number or number 1. I've just taken one example out of my mind. It may be looking very odd, but yes, 1. So sure events, definitely this is going to take place. Either this will happen, odd prime it will come, or it will be an even number, or it will be a number 1. So sure event is that event which is basically a sample space only. This is that because it is going to happen for sure. Simple event in which only one sample point is there. So these are all sample points. Okay, these are all sample points. In any event, the incidences taking place are all sample points. So simple event is the one in which only one sample point is there. For example, if I say two, let's say two dice are rolled, two dice are rolled, and I want that we get exactly two head. So exactly two head means this is the only possible outcome, favorable outcome. This is the only possible favorable outcome. So this only one sample point. So therefore, this is our sample point, simple event. And compound event is the one in which there are more than one sample points. Let's say in the same example, if I say that I want minimum one head, so what are the possible favorable outcomes? So head, tail, head, and head. So sorry, I have taken the case of coin. So just please excuse me. So there are two coins in this example. So yes, so head tail head, and head. So these are our compound events because there are more than one sample point. There are total three sample points. And when we say that I want exactly two heads, so there is only one sample point. So therefore, uh, the difference between simple event and compound event. Complementary event, as we have already seen, probability summation of probability of any event and the complement of that particular event. The summation of these are equal to 1. And event A, or let me just clean this a little bit. So yeah, so event A or B, so this is expressed as union of events. So when I say event A, and let's say I say event B, here it is A, here it is B. So summation of these two will be either A, okay, either A or B or both of them. So when we say either A, so either A means A minus the only A, means there should not be any part of B, and when we say B, so there should not be any part of A, and whatever is the common intersection or maybe the common overlapping part between them. So this we will be learning again in the great detail when we in later part. So events A and B, so event A and B is the overlapping part or the intersection part. So it is expressed as intersection like this, event A or A and B. So intersection of A and B, mutually exclusive events. So when we say event A and event B, so there is nothing common between them. So we simply say that that there's nothing common, nil is common between them. So again, for example, can be seen for this mutually exclusive event is like if I roll two dice and if I want on first dice a number, let's say even number, so it's 2 4 6, and on the second I want an odd number, so 1 3 5. So definitely there is nothing common between them, so these two are mutually exclusive events. But when we say that we want even number on the first die and on the second die we want let's say prime number, so prime number are 2 3 5. Okay, so there is two common between these two events, so these two events are not mutually exclusive events because there is something common between them. So that's the definition. So again we have seen this. So when we do A union B, that is, so we do the addition, or we take the A part without B, then we take B part without A, and then whatever is the common area between them. So we say A plus B, So A means only A part. So when we write A, but A is whole circle, so we have to, let's say this we denote as X, this we denote as Y, and this we denote as M, the intersection part. So how do we write this? So we write it X minus M, because we want only the part which is not in containing B. So we want only this part. Okay, so this is X minus M, plus we want B without any part of A. So we will do, so we will, from the circle we will minus this particular portion which is overlapping, so this will be Y minus M, and then whatever is left, because we want whole A plus B, so whatever is left is M, so this will be X plus Y, when M we can cancel out, so this is like this. So what we get, so A union B, when we do, we get A plus B minus A intersection B. So similarly when we do probability, so probability also becomes like this. So yeah, here it is written also, I just forgot. So same thing what we have mentioned. So again, these are our mutually exclusive events. So in this case, when we do the summation of, or when we want to say that, see that what is the union of A and B events, so it will be only summation of these two, because there is nothing common between them. So simply we can add them. So let's quickly go through each of the four cases and try to draw a sample space or maybe sample events. A coin is tossed, and first one, a coin is tossed and then a die is rolled. So coin is tossed and then a die is rolled. So die is rolled only in case a head is shown. Okay, die is rolled only in case a head is shown on the coin. So when head turns up, then the die is rolled. Okay, so we can simply draw like this. Or only tail, when the tail comes up, then there is no rolling of die. Okay, so here is only tail. So what are those possible outcomes? So head 1 or head 2 or head 3, this I am taking this case, head, sorry, head 3, head 4, head 5, head 6 or tail. So these are our sample space. Now second part, a boy, two boy and two girls are in class in room X, and one boy and three girls are in room Y. So in X, I will just delete this particular part. We will do this one. So in room X, we have two boys and two girls. In room Y, we have one boy and three girls. Okay. So again, sample space, when we for experiment in which a room is selected and then a person. Okay, let's say room X is selected and then a person. So how many possible outcomes, combinations are possible? So X, let's say B1, B1 is for boy 1, then X B2 is for boy 2, then yeah, then X G1, X G2, then if Y is selected, then Y, let's say B3, here we say boy 3, then YG3, girl 3, YG4 and YG5. So these are all our sample spaces. A die is rolled, let E be the event, die shows 4. Okay, so this is E, and F be the event that die shows an even number. So F is our 2, 4, 6. Are E and F mutually exclusive? So E and F are no, because there is common between them, 4 is common, so they are not mutually exclusive. Sorry, not mutually exclusive, or we can say that E intersection F, that is in between them, what is common? So there is nothing common between them. Okay, so now let's move to next example. Say three coins are tossed once three coins are there. These are tossed once. Let A denotes the event three heads show. Okay, so A says three heads. B denotes the event two heads and one tail. Okay, so B basically two heads and one tail. So possible combinations will be head, tail. Sorry, let me just. Oh, sorry. Again, we will write again this one. So our A is three three heads. B is two heads and one tail. So this how many total number of possible outcomes? So there will be 3 factorial by 2 factorial. This I hope you have learned in permutation combination, but in our video also you can watch for more clarity. A detailed discussion is there on our video on permutation combination, which will be coming very soon. So and we can write those combinations also. So this will be 3. So what are those? So H H T H T H and T H H. So these are 3 possible outcomes for B, and then C is our uh, three tails show. Okay, so this is pretty simple, and D denotes the event a head shows on the first coin. So head comes, then whatever anything can come. So let's say head comes, so here all the heads are there, or here then one tail is there, then here this can be written as this also, these two. Then what? Then we can say that only one head and tail. So these are total 4. So which events are mutually exclusive event? So definitely A and C, because there's only tail and there's only head. So nothing common between them. So definitely A and C are mutually exclusive event. And simple events. So again A and C are simple event because there's only one sample point. And compound event, so yes, compound event, so B is also a compound event. There are total 3 sample points, and compound events are those in which there are more than one sample points, and definitely D is also a compound event. So with this, just again it has stuck. Yeah. So quickly we will see this question. In class 11 of a school, 40% of the students study mathematics and 30% study biology. Okay. So 10% of this. So we will solve this question in two different forms. First, the one form will be like what we have learned in our textbook and CRT books or in schools, and other one which I am going to tell you and which I will recommend that you should definitely try and use this particular approach in your all competitive or JEE exams, or even in your classroom exams also you can very well approach, but in definitely in competitive exams including JEE. So let's draw the mutual exclusive. So first we will read the question fully. So 40% of the students study mathematics and 30% study biology. 10% of the class study both mathematics and biology. If a student is selected at random from the class, find the probability that he will be studying mathematics or biology. Okay. So what we will do here in our approach, so we will write here as mathematics as M, and then we will write the complement of M, that is mutually exclusive. So which is complement M dash, we will simply denote this. Those students who don't study mathematics, we will denote it like M bar, and then we will say here total, and then here for biology we will again do the same thing, B for biology, and those students who don't take biology, and then here total. So we will simply fill these cells as per given information. So 40% of the students study mathematics, so here we will write 40, and 30% study biology, so here we will write 30 because biology is here. 10% of the students class study both mathematics and, so mathematics and biology, 10% will come here. So total percentage, so it is 100 because it is given in a percentage form. So whatever number are not known, we will simply write from here. So I will take other color. So this is 7 because combined together it should reach to 100, and likewise here also. So it will be here 60. So for this it will become 30, this will become 20, and this will become 40. Now what is being asked? If a student is selected at random from the class, find the probability that he will be studying mathematics or biology. So we want either he is studying for mathematics or he is studying biology. So that means we will take again different color. Let's say this blue. So mathematics, only mathematics means what? Any student, those students who are studying mathematics but not biology are 30. Okay, so we will write 30 plus those students who are studying biology but not mathematics, so those are 20. So yes, we will write 20 plus those students who are studying both mathematics and biology, so those are 10. So how much? 30 plus 20 plus 10, that is 60. So 60% of the students are studying mathematics or either mathematics or biology. Okay, now in our conventional approach, what we have seen or learned in our schools, so it will be like this. So we will simply draw two circles. So here is circle of maths and here is circle of biology. So this is maths, this is biology, this is 40% and this is 30%, and this common part is 10%. So now what we have been asked that those students who are studying either mathematics or biology. So how do we do this? So what we have to do, we will take some other color, let's say red. So what we have to do, we simply will take this particular part which is only mathematics. So how much this will be? 40 minus 10. Then we will be taking, let's take let's say black color. So this particular part which is only biology, so that is 30 minus 10, and then we will be taking the common part which is mathematics and biology, so that is 10. So it will 110 110 we will simply cancel, then 40 plus 30 70 and minus 10 is 60. So 60%. So do it like this or do it like this, we get the same answer because conceptually we know that what we are doing. Or we can simply fit the formula if not, if it is so simple. But exams normally you will not find any question of this simplicity, but we should know the approach and the formula part also. So what it says, that if PA union B is equal to PA plus PB and minus PA intersection B. So why we do this minus? We have seen we do that just to avoid the recounting of this particular shaded or the overlapping part. Okay, so because when we do the PA union B, that is summation of A and B, so when we add A and B, so here the common part is counted twice, so that is why once we subtract this particular part. So formula also, it's intuitively we can learn, there's no need to memorize it. So when we do fit these values, so what will happen? So PA is given as 40, PB is given as 30 and minus 10. That is the common part which is 10. So it will be again 60. So do it either way, but I will strongly recommend you should practice this particular method, because when the level of question goes up, so here we can simply see those numbers and we don't have to apply any formula or any other, we should conserve our energy in the mind when we solve the competitive, when we write any competitive exams, because time is the biggest pressure. And given if time we have sufficient time we have, then most of us will definitely do well in competitive exams. But the only deciding factor, which to my opinion, is the time pressure. So in time pressure, if we can save some precious time on identifying the common part or the intersection part or maybe the union part by drawing these sets, if we do this, we will save on a lot of precious time, and it will help us in thinking, giving more time to the more tricky part of the question. So with this, we will move to the next question. Again, in an entrance test that is graded on the basis of two examinations, the probability of a random chosen student passing the first examination is 0.8, okay, and the probability of passing the second examination is 0.7. So if, let's say, two exams over there in the entrance test, so if we choose randomly any student, so that student having cleared the first exam, the probability of that is 0.8, that is 80%, and probability of passing the second exam. So if that student, the probability that the same student has passed the second exam also is 70%. So, and the probability of passing at least one of them is 0.19, 0.995, that is 95%. So, what is the probability that if we select any student randomly, so at least one of them, that is either exam 1 or exam 2. So, we will again simply and quickly, uh, you know, try both the approaches what we have seen now. So, we will draw the mutually exclusive events on one side. So let's say first exam, we will write this as like this: first exam, then those who have cleared first exam and those who have not cleared first exam, and then total we will write here, then second exam, those who have cleared and those who have not cleared, okay. So and then total. So what it says, 80% chance for first exam, so like this, write this here, and then probability of passing the second exam is 0.7, so here it is 0.7, we will write this in point form only, and then the probability of passing, okay, the probability of passing at least one of them, at least one of them means what? So either he has cleared first exam but not the second, that is this one, or he has cleared the second exam but not the first, so that is here, or he has cleared both the exams. So that means if we say A, B and C, so A plus B plus C is equal to 0.95, okay. And what else is given? So here we can write this as 1, so this will become 0.2 and this will become 0.3, and so what we can see here, so let's take this as A plus B plus C is given from the question that it is 0.95, and how can we do this? So we can write this A plus C is equal to 0.7, from here we can see, and similarly A plus B is equal to 0.8, from here we can see. So we can simply solve this, and so when we solve, so what we have to do, A plus C we can substitute here, so we will get uh, B plus A plus C is 0.7 is equal to 0.95, that means B is our 0.95 minus 0.7, so it will be like, 5 and 0.25. Let's check this one. Yeah, so B is 0.25, so we have got our B. So and what about, so we can also substitute A plus B, here. So once, because B we have already got 0.25, so A will be 0.8 minus 0.25, so this is 0.55, so A is our 0.55, and what about our C? So let's see what we need to find. We need to find what is the probability of passing both. So what is the probability of passing both means A and B. So A and B we have got 0.55. So it is 0.55. But when we do this other way, so let's draw this. So here first exam, here second exam, here is the common part. So first exam is 0.8. Let's say first, then let's say here write second. So it is 0.7, and the passing of at least one of them is 0.95. When we say at least one of them means passing of none of them. Okay, so it will be the this part plus plus this part and this common part. So summation of all these three together will be 0.95. So we can simply apply this formula and we will get the same answer. So that is why I am saying here that इस method को लगाना is more convenient and easy to solve. Now let's see the question which has appeared on in JEE Main 2019. So let's take some other color. So yeah, in a class of 60 students, 40 opted for NCC, 30 opted for NSS, and 20 opted for NCC and NSS. So again we will do this. NCC, those who have not opted for NCC, then NSS, and those who have not opted for NSS, and then total, and here also total. So what it says, in a class of 60 students, total students are 60, 40 opted for NCC, okay, and 30 opted for NSS, okay, and 20 opted for both NCC and NSS. So here it is 20. Other cells we can simply fill. Let's change the color. So here it will be 20, here it will be 20, here it will be 30, here it will be 10, here it will be 10. So what is the question? Find the probability that the student has opted for neither NCC nor NSS. Means this is the answer, 10. Without going through any formula or without doing any other calculation, we have simply calculated this as 10. This number we have found, but what is the probability? So probability is 10 by 60. Total number of students are 60, so it will be 1 by 6. So answer is A. And again we can, the conventional method. So NCC is like this, NSS is like this. NCC it's 40, NSS is 30, and the common part is 20. So when we have to find or have neither opted for NCC, so neither opted for NCC or NSS, and that is complement. So it can be written as NCC union NSS whole complement, or this can be written as 1 minus NCC union NSS. From here we can simply find. Now let's move to the next question. The probability that a student will pass the final examination in both English and Hindi is 0.5, and the probability of passing neither is 0.1. Okay. Probability of passing the English examination is 0.75. What is the probability of passing the Hindi examination? Let's draw it. So let's draw it like English and no English, means those who have passed the English exam and those who have not passed the English exam. And then Hindi, not Hindi, total. So let's fill the numbers. So student will pass the final examination in both English and Hindi is 0.5. So here it is 0.5. Probability of passing neither is 0.1. Okay, so this is 0.1. If probability of passing English examination is 0.75. Okay, so this is 0.75. What is the probability of passing the Hindi examination? So here we will write this as 1, and here it will be 0.25, here it will be 0.25, so here it will be 0.35, and here it will be 0.65, so here it will be 0.15. So what is the probability of passing the Hindi examination is 0.65, that is 65%. So simply we have found the answer, and we can use conventional method also, which I am not going to, because otherwise it will take a lot of time. So in the interest of time, we will move ahead. So again, this question has appeared in JEE Main 2020. So the question says, the probability that a randomly chosen 5-digit number is made from exactly 2 digits is. Now this is a different question what we were doing till now. So let's see. Total number of possible outcomes are. So what the question says? Question says that if we have 5-digit number we have to make. So let's draw 5 dashes, 1 2 3 4 5. So 5-digit number we have to make, and we need to use 2 digits exactly 2 digits. What means not less than 2 digits and not more than 2 digits. It has to be exactly 2 digits. How many numbers we have? We have 0 to 9, that will total 10 numbers. Now to make a 5-digit number, definitely this particular space can't be filled by 0. So for this space we have total possibilities from 1 to 9, and therefore total 9 possibilities. So this space, this digit can be filled in 9 different ways from 1 to 9, and this space can be filled in any of the, this we are finding, what we are finding, total possible outcomes in this situation. So then this can be filled in total 10 ways. Why? Because any number from 0 to 9 can be pegged. So this also, because repetition, nothing is written about repetition, that means we will assume that repetition is allowed. So again, this in 10 different ways, this is 10 different ways, this is 10 different ways. So total number of possible outcomes are 9 into 10 to the power 4. Now let's do one thing. Let's write it little clearly. So first is total possible outcomes. This is, we will draw a line here. So 1 2 3 4 5, this can be filled in 9 different ways, because 0 we can't take, and this 10 ways, 10 ways, 10 ways, 10 ways. So 9 into 10 to the power 4 total possible outcomes. And now see the favorable outcomes. It says exactly 2 digit needs to be used in making 5-digit numbers. So again we will, we will again draw 5 spaces. Now see, we are here having few options. Option 1, or we can say case 1. So when we pick only non-zero numbers, so that is our case 1 or option 1. So when we pick only any non-zero numbers, so the total 0 to 9. So picking 1 to 9, because non-zero. So 1 to 9, from 1 to 9 we have to pick 2 numbers. So what are those combinations? So it is 9C2. From these 9 numbers we can pick any of 2 numbers. So what are those combinations? From combination permutation we know it is 9C2. And then from these 2 numbers, so because these are non-zero numbers, so we can use this in 2 different ways. It can be filled, it also can be filled in 2 different ways, 2 different ways, 2 different ways, 2 different ways. So let's say we have taken, for example, we have taken 4 and 5. These 2 numbers we have picked from 1 to 9. Okay, 4 and 5, for example, there can be any 2 combinations. So when we take 4 and 5 as 2 numbers, so this digit can be filled, can be written as either 4 or 5. Similarly, this can also be written as 4 or 5. Similarly, this digit can also be written as either 4 or 5. Similarly, 4 5. Similarly, 4 5. So what are those? But here the problem is that we should eliminate that particular case in which all the numbers are same. So that means it should not happen like this, 4 4 4 4 4, or it should not happen like this, 5 5 5 5 5. So there are total 2 cases. Such cases are 2, so we need to subtract these 2 cases. All other cases are our favorable outcomes. So that means 2 to the power, how many? 5 minus 2. And option 2 or case 2 will be when we pick 1 0 and 1 non-zero. So 1 0 can be pegged in only one way, non-zero. So non-zero again, it can be pegged in 9 different ways from 1 to 9. Any from 1 to 9 any number has to be pegged. So any of the 9 numbers can be pegged. So now draw again 5 spaces. So this number can't 0 can't come here. So this number can be filled in total 9 different ways. Okay, and what about other 4 places? So other 4 places, so here 0 can also come, here also 0 can come, so these can be filled in how many? 10 different ways. So 10 ways, 10 ways, sorry, not 10 ways, 2 numbers we have one is 0 and one is any other number. Any number means either 1 2 3 or any number. So this can be filled in 2 different ways, 2 different ways, 2 different ways, 2 different ways. But again, we should not, let's say first number is, let's say our 1, so all the numbers will 1 1 1 1, we should avoid that particular case. So but there's only one case, because 0 we have already not used 0 in first case, because otherwise it will not be a 5-digit number. So we need to eliminate minus 1 that particular combination. So what will be the case? 9 into 2 to the power 4 and minus 1. Okay, so means possible favorable outcomes are 9c2 to the power 5 minus 2, or 9 to the power 4 minus 1. So we need to solve this. 9c2 is what? You can simply solve here. 9 into 8 into 7, sorry 7, yeah 7, and then here also 7 and 2. So this 7 and 2 into 4 8. So 9 into 4 2 to the power 5 means 32, minus 2 plus 9 2 to the power 4 means 16, minus 1. So it will be like 9, we can take out the common 9. So 32 minus 2 is 30. 30 into 4 is how much? 1, so 120, and this is 15. So this will be 9 into 135. And what is our total possible outcomes? 9 into 10 power 4. So we need to divide this to get the probability. So 9 into 135 divided by 9 into 10 to the power 4. So 135 divided by 10 to the power 4. So yeah, this is our answer A. So I hope you enjoyed this question. Now let's again see one question which has appeared in JEE. So if 3 of the vertices of a regular hexagon are chosen at random, then the probability that the triangle formed with these vertices is equilateral. So we know that in a hexagon there are total, regular hexagon, there are total 2 possible equilateral triangles, and these are like this. So we will, just a second, so we will do one thing, we will take the other color so that it is clearly visible and known. So this is our triangle 1 which is equilateral, and then we will take the red green color. So this is our triangle 2, and how many vertices? 1 2 3 4 5 6. Out of 6 vertices, total 3 vertices have to be chosen. So total possible outcomes are 6 C3, and number of equilateral triangle formed are 2. So their probability is 2 divided by 6 C3. So 6 C3 is how much? Sorry. So 6 C3 is 6 divided by 3, 3, 6 into 5 into 4, 3 into 2, so it will be 20. So 2 divided by 20 means 1 by 10. So our answer is A again. So important concepts. So we have almost completed our first part of the today's session. So this was more focused on the 11th syllabus. This syllabus which is covered in given in 11th standard, and the more important part will come up now. And but in this video we will be just in this session we will be just touching, and in next session we will be discussing more on detail, and we'll be doing more focused question on this. So random experiment, there's no need to tell, we already know random experiment is any experiment on which there are definite number of outcomes. So well defined outcomes are there, like when we roll a dice, so we know that any number from 1 to 6 can happen. We don't have any uncertainty or that gray area that what will happen or what can come. So anything can come, but those outcomes are well defined. So outcomes are possible from 1 to 6. So first, this is the first criteria, that the outcomes should be well defined. Sample space, only one possible outcomes. So every time we roll a dice, so only one possible outcome is possible. It can't happen that between one or between two numbers, some, like, it is not a quantum. So we should simply say that see that only one possible outcome is possible on every trial, and the outcomes are solely by chance. So it is not fixed that this particular outcome or this particular event will take place. No. So every event has its own chance. So if we want a number on a prime number on when we roll a dice, so prime numbers are 2, 3, 5. So the chances are 3 by 6 or 1 by 2. So any prime number coming up when we roll a dice is 1 by 2. So therefore outcomes are solely by chance. We can't say for sure or for with definite that this particular event will take place. So conditional probability, yes, these now are important ones, and on these topics or these concepts क्वेश्चन हमारे कॉम्पिटेटिव एग्जाम्स में फिर हमारे जेई में बहुत ज़्यादा आते हैं. इनका डायरेक्ट यूज़ भी, डायरेक्ट क्वेश्चंस भी आते हैं, प्लस इनके जो मतलब यूजेस हैं, एप्लीकेशंस हैं इन डिफरेंट क्वेश्चंस, डिफरेंट सब्जेक्ट्स पे, सॉरी डिफरेंट टॉपिक्स पे, उस पर भी बहुत ज़्यादा आते हैं. So conditional probability is simply when any particular event has already taken place, then what is the probability that particular event X other event will take place. So इसको भी हम ग्रेट डिटेल में अभी आगे देखेंगे और समझेंगे. So independent events are when two events, when we say that the outcome of one event will not impact the outcome of the other event, or it has no bearing or it has no effect on the happening of the other event. Multiplication law is simply derived from these two only, so we can intuitively understand, but in next session we will be covering this in great detail or depth. And Bayes theorem is just from conditional probability only. When in conditional probability, what happens that in conditional probability, let's say that we let's say what to say, yeah. So when dice are rolled so now what is the probability that that even prime will come, given that the out sorry take just example of one die. So even prime will come given that the outcome is a prime number. So this is the conditional probability. What is the probability? Sorry, what is the probability that the even prime will come when the given that already prime has occurred? Okay, so when we know prime has occurred, so 2, 3, 5. Out of these 2, 3, 5, what we want 2 only. So this we denote like this: P A by B, that B has already happened. Then what is the probability of A taking place? Here B is 2, 3, 5 and A is our 2. So this is very easy to understand and it's very easy to solve. So when we already have given that 2, 3, 5 are the possible are the events which have already taken place, so get finding 2, we will be seeing this in while we solve the problem. But in Bayes theorem, we are given to find the opposite side, like we need to find the source, that if let's say 2 3 5, let's say 2 has happened. So what is the probability that, or we need to take some other example, that if any a particular event has happened, let's say there are two boxes, box A and box B. Here some balls are there, here some balls are there. So if somebody says here, let's say two white and four red balls are there, and here in box B one white and five red balls are there. So in Bayes theorem it says, let's say, what is the probability of of selection of B box, given that ball drawn is a red ball. Now here it is opposite. So why opposite? That we are already given an event, but the source of that is being asked. But in the conditional probability, source is given. Source is given means box B, given that what is the probability of selection of red ball if box B is selected. In this, it will be given like this in conditional probability, that what is the probability of selection of red ball if box B is selected. But in the Bayes theorem is applied when the question is asked in reverse direction. That is, we are required to find the source with the condition that particular event of that particular event has already taken place, like in this case. So we will not delve